The next thing you need to do is determine the length of time for the PR interval, QRS complex, QT interval, and heart rate. So if we take a look at what we're looking for this location just before the P goes up, and then as it continues on and it stops right before that Q value. So that's going to be kind of tricky to find on our waveform, because just before the P goes up is a little bit easier. It's somewhere around here. But that Q actually, and I'm realizing it now, it actually should probably be right here, because this is the decline of the P, and then it straightens out, and then right before we spike up is our actual Q. So again, it's a little bit tricky to find on these. I can click the plus to zoom in a little bit more, so I can see a little bit more clearly. And then if I see this double squiggle on the bottom of the graph, I can kind of center that so I can see my waveform a little bit better. Zooming in a lot will definitely help make this a little bit easier for you. Again, you could also zoom in by just clicking on the squiggle with the solid bar once you get really far to the left of the x-axis and really far to the right. So if I want to identify the beginning of the P wave, it looks like somewhere around here. So I can just click, as long as I see the crosshairs, I can click and drag, and the Q is over here. So I'm going to stop before the Q. So that looks like somewhere around here. So again, that's not a typical P wave, but there is no real typical electrocardiogram. They all look a little bit different. So this one, it goes down and then kind of straightens out before that Q wave. So it looks like this is a fairly decent selection for the range. So if I move my mouse down below, I can see this delta T is 0.177. That tells me the amount of time for the interval that I've selected. So I'm going to use that 0.177. I'm going to go back here to my data is 0.177. And then I want to look to see, am I within that range? What is a normal PR interval? What says 0.12 to 0.20? And it does say 3 to 5 small squares. It depends on the tool that you're using to read this. We're not actually using that. So we're just looking at the amount of time here. And that looks like it's within range. So I can type within range for this one. Now the QRS complex from beginning of Q to the end of S. So we could measure that. I'm not going to do that. I'm going to let you do that. But let's say I get a value that's not within this range. Let's say I get a value that says it's 0.05. Well, you can see that that is 0.03 less than that. So to calculate that, again, it's 0.08. That's the smallest QRS complex value, minus 0.05 gives me 0.03. So you could say I'm 0.03 below range. So that will be your answer for this one, if that's the situation that you're dealing with, right? Now, you might be within range. You might be 0.09, 0.10, 0.11, 0.12. Then you're within range in that too. So I'm just giving this as an example for how to calculate if you're below or if you're above range, if it's a number larger than this. Now let's move down to heart rate, because QT interval again starts here and ends at the end of that T line. So again, you have to sort of look at your graph, try to identify where those locations are as best you can. Now the heart rate we're going to identify from R to R, so from peak to peak. So we don't really want to use one heartbeat to find the heart rate. That's going to be very accurate. From here to here is one heartbeat. But we need to figure out how many seconds it takes for a certain number of beats, and we can compare that to how many beats we would get in a minute. So let me zoom this out. So I could click the minus button here, zoom out. The only problem is it also zooms out in the y-axis, so it can get pretty short in a hurry. That's okay, because I can still see these peaks pretty clearly. This gives me enough to be able to make a measurement. So I'm going to select this one, and I'm just going to count a few out. 1, 2, 3, 4, 5, 6, 7. Let's just do 8 beats. So I have 8 beats from peak to peak. And that took 7.079 seconds. So if 8 beats is 7 seconds, then how many beats is 60 seconds? So hopefully that's sounding to you like a proportion. So let me write that down. 8 beats equals 7.079. I can set that up to X beats equals 60 seconds. So I want to set up that proportion. And hopefully this is starting to look familiar to you. If I underline, you can see that these are fractions. 8 beats over X beats is 7.079 over 60 seconds. So now we cross multiply and divide. 8 times 60 divided by 7.079. will give you your answer in your heart rate. So how many beats you get for that. So you can just do your work, show your work directly right here, and then type your answer in there. And there is no solution for this. We don't need to put within range, above range, below, because we don't really have anything we're checking. So this just gives you the number of beats. So make sure that you label that with how many beats that you're getting per minute. That is your true heart rate. Now, before I let you go on this, there's one other question. Look at the EKG and measure between the R spikes. Does it appear the patient has heart arrhythmia? Well, arrhythmia is where the heart rate is changing over time. So we can check for arrhythmia by measuring, well, how much time did it take from this beat to this beat? And I can take a look at that value. How much time did it take between this beat? And how much time did it take between this beat? So as you're measuring these over time, if there is a drastic variation, like we're saying this one has a measurement of 0.943, and then I go to the next one, and that's maybe looks pretty close, 0.927, but then it's maybe 0.8 and then 0.6 and then 1.2 and 1.4. If there is a drastic variation between them, that's a good indication of heart arrhythmia. So that's what you can check to see on that. So check a bunch of these, see what the time is. We don't need to actually calculate the heart rate, just what is the time difference in between them, and that will give you an indication of whether or not there is an arrhythmic issue at hand. That should be all you need to do. Then once you finish that, you can answer the rest of these conclusion questions, and then you can submit this by clicking share in the top right corner and sharing this with me.